Hi, in this video, contents about pre-flight checks will be shared. In pre-flight checks, first of all, the condition of drone parts should be checked by eye and hand control. That is, whether there is a looseness, tightness, rubbing, battery health, that is, temperature and charge level and voltage status of each cell must be checked. Motor functions and propeller inspection are also a great information at this stage. Next, the compass must be calibrated and strength of GPS signal checked. After testing the UAV's control signal, the gimbal camera and sensor should be checked to ensure that they are working correctly. In addition, the UAV technical capacities and specification should be reviewed to ensure that they are suitable for flights. Finally, the flight environment should be assessed, airspace and local regulatory compliance checked, and the flight mission planned accordingly. Several basic steps should be followed when assessing battery health. Firstly, the battery should be checked for any swelling, deformation or leakage by visual inspection. The connector should be also inspected for signs of corrosion or damage. For voltage testing, a multimeter or smart battery controller should be used to measure the voltage of each cell to check that the values are in accordance with manufacturer specification. For capacity testing, a battery analyzer should be used to perform a discharge test and compare the actual capacity to the nominal capacity. If the capacity is below the value determined by the manufacturer or falls below desired safe flight time, the battery should be replaced. Finally, using a battery analyzer with an internal resistance test function, the measured results should be compared with the manufacturer technical specification. High resistance values indicate the battery deterioration. During motor testing, first a visual and physical inspection is performed. The motor's external body should be checked for any residue and by manually rotating motor to ensure they rotate freely. When calibrating the ESC, the manufacturer instruction must be carefully followed. In the motor rotation test phase, first remove the propeller and use the drone's built-in motor test function or manual controls to check if each motor is rotating in the correct direction and listen for any unusual sounds. Finally, a current draft test should be performed. Using a power meter between the battery and drone, run the motors at different speeds and compare the current draw with the manufacturer specified current draw value. Three main steps must be followed in propeller inspection. First, truly visual inspection, check for notches, cracks, any deformation on the propeller. Also ensure that the propeller are clean and free of residue. In the second step, check the tightness of the propeller and ensure they are mounted correctly and securely. Finally, use a propeller balance device to test whether the propeller are balanced and replace those that are unbalanced. When performing GPS signal control, first select an open area with a clear sky view, then turn on the drone and controller, wait for GPS lock and check if the minimum number of satellites specified by manufacturer has been reached. When proceeding to the position health testing, fly the drone at low altitude and observe its stability and drift. Finally, check the GPS position accuracy in the application. Sensor controls are crucial before flight. When calibrating the compass, choose location free from electromagnetic interference away from large metal objects, and electrical lines. Then start calibration using your drone application or control device. During calibration, first rotate the drone 360 degrees horizontally, then 360 degrees vertically. For some drones, infinity symbol movements may be required. Finally, confirm successful calibration through interface warning. The remote control signal test consists of three main steps. First, a distance test is performed. Following the manufacturer instruction, fly the drone at low power over the short distance to check for any signal interruption or delay. Second, perform the control response test. Test all control inputs such as pitch, roll, and yaw and throttle to ensure drone responds smoothly and instantly. Switch flight modes onto remote control and test through interface that modes change correctly. Finally, fail safe test should be applied. At a safe height, turn off the control and verify that drone enters safe mode. In other words, return to home mode. To perform gimbal calibration, use the drone application, ensuring the drone is on a flight surface, and adjust the gimbal horizontal straight. Then perform gimbal movement tests on all axes to check if gimbal works smoothly across its full range of motion and check for any vibrations. Finally, verify camera settings like resolution and frame rate. Then take a photo and a short video to evaluate image quality. For IMU control, place the drone on a flat surface and check status readings from application, ensuring the drone's completely parallel to the ground. Then slightly tilt the drone to confirm status change. To perform obstacle avoidance testing, slowly move your hand or an object towards each sensor to ensure the sensor detects obstacles. For barometer control, observe that initial altitude reading, slightly lift the drone and check through application interface if the altitude change is correct. It is crucial for drone operator and technician to know the technical capacity and characteristic of drone for safe and effective flights. This knowledge is necessary to optimize flight performance, make mission-appropriate selection, and be prepared for potential failures. These checks include battery capacity and flight time, payload requirements, maximum takeoff weight, signal strength, camera features, storage capacity, CPU processing power, and transmission quality. Drone operators must carefully evaluate pre-flight environments. Factors like wind speed, direction, visibility condition, temperature range, precipitation situation, humidity level, and air pressure are critical for flight safety. Additionally, consider the sun's position and potential glare effects, electromagnetic interference sources, and radio frequency interference levels. When planning flight, it is important to comply with airspace rule and regulation. Pay attention to flight areas restriction to obtain necessary permission, adhere to altitude limits, maintain distance from airports, perform NOTAM checks. To be attention of privacy rules. Also, operate in accordance with local regulation and predetermined landing zone for emergencies. When planning flights, define the flight purpose and plan a route appropriate to that purpose. Clearly define waypoint settings, altitude, and speed requirements. Consider potential camera angles and evaluate obstacles. Prepare emergency procedure for each flight and determine alternative routes for such situation. Know A pre-flight checklist will be supplied. First, is the flight area at a legal distance from airport as determined by local authorities? If so, is there any permission from air traffic controller? Is the flight area an approved drone flight zone by local authorities? Is the drone firmware up to update? Is the remote control firmware is up to date? Are there any visible defects on drone? Are batteries fully charged? Are batteries securely installed? Are propellers properly mounted? Is the memory card inserted in the camera? Are the antennas extended? Has the compass been calibrated? Has the return to home altitude been set? Has the flight ceiling altitude been determined? Is the takeoff area on flat ground? Is the flight area safe for takeoff and return? Are the people or obstacles in the flight area that could impede takeoff? Operator's name, surname, signature, date, time, approving safe takeoff. We have covered drone pre-flight checks in this video. I hope the contents have been helpful. See you in next contact. Goodbye.